Inequalities are solved the same as equations except when you multiply or divide by a negative number. In other words, when you solve that last step, if you have a negative 5x is greater than 20, okay, you must flip the sign. So that greater than would become less than. Okay? Here's a chart of words or phrases associated with the inequality symbols. What do we call this one? Anybody know? Pretty simple, less than. It also can be known as is fewer than. This one is less than or equal to. It is also known, it can be when they use the words at most. It can be no more than, maximum value. So those are all terms in a sentence that if you were having to create the equation, which is actually an inequality, you would be looking for those words if you were using that sign. This sign is greater than or equal to at least, no less than, minimum value. I know I'm kind of going a little bit fast here, okay? The issue is that these notes are long and we need to get through them, okay? We are like way behind due to all these interruptions in class. Also, originally I was going to give you your test on Friday. That's not going to happen, okay? We're not ready and we still have stuff to cover. Then I was going to do it on Monday, but we've got volleyball. Then I was, every day something's going on. So Monday we're going to do part 1, which is only about 20 minutes. So those of you in volley, is it this week we're doing the test or next week? Anyways, it's on the 28th. Yes, next week. We're going to do part 1 on Monday. It's only going to shouldn't take you more than 15, 20 minutes. The rest of it will be done on Tuesday. Okay? And then we've got to hit the road again. But we've spent way too much time on this. Next one is greater than and is more than. Okay? If you have this, okay, and it's on a number line or part of a graph, it means the open dot means the number is not part of the solution set. Thus, it is not shaded. The open dots are less than, greater than, or not equal to. That's when you would use an open symbol. A filled in closed symbol or dot means the number is part of the solution set, thus it is shaded. And these are examples down here. If you have something on a number line and it says x is less than 2, here's the symbolic description, x is less than 2. Here's the graphing. In other words, this would be the number line where x is 2. Okay, and we're going to practice that. Graphically, if you have this and it goes all the way across and doesn't stop, it means that it's the set of all real numbers. Okay? And of course, a 0 with a line through it means no solution, no graph, since no number works. Examples of that. I guess I don't need to write the word examples. I've got it there. If I had 6 is less than 3, is that a true statement?
No.
No. Therefore, that's that set, isn't it? Okay? If I had 6 is equal to 3, is that true?
No.
Nope. So therefore, again, it's the empty set. This is the set of all real numbers. So when it's the empty set or no solution, that is how we notate it. It's a double. Well, if you see this over here, it's kind of like a fancy little R. I just put 2 lines down and then just do an R. Yeah. Okay. And you know, set notation, you're supposed to have it in a set here, like this, okay? That's actual set notation, so it would be the empty set. Let's see here. Here we go. Okay, so let's look at this. It says, example, translate and graph the solution set for the following sentences. A number Q is less than 2. How would I write that? Q. And then I need the what sign? Less than 2. Now, is it going to include 2? So you do an open circle around 2, and you put your little line, or you make an arrow, and you go this way. Okay? It says X is greater than -4. So you're just going to write, because here they want you to write the sentence. So a number is greater than -4. So this time you're writing the number. They gave you the symbolic or the equation for it, the inequality. And then on a graph, is it including -4? Really? No, it doesn't say greater than or equal to, does it? So open circle, line going this way, greater than. Okay? Given the following graph, write an inequality and a word sentence. So what are they showing us here? They're showing us a line that starts where? At 5, and it's actually including 5. That's why your circle is darkened. So what can we say? I can say X is, very good, 5. Okay? That's what it's showing. So then I could say a number is less than or equal to 5. Or I could even say it, a number is at most 5. Same thing. And I'm just showing you some examples. Remember, these examples will be very much like your work. Okay? Everybody good? Okay. Given the word sentence, inequality, or graph, write the other 2 representations. So y is less than -4. Come on, you guys can write that, can't you? Y is less than -4. Boom. Then you've got a number line. Just create it any way you would like. I'm going to just kind of go here and say this is 0, 1, 2, 3, 4. So this is going to be my -4. And I'm going to do an open circle, and I'm going to draw it in. That's not difficult, is it? No? Yes? Maybe so? Okay. All right. Now we've got K is no more than 7. So how would I write no more than? Look at the front page. What symbol is going to be no more than? Less than or equals to, right? 7. So there again, I'm just going to come over here, and you're just going to have to move your number line. 0 doesn't necessarily have to be in the middle, okay? You can make it wherever you'd like. So if I make 0 here, 1, 2, 3, 4, 5, 6, 7, am I going to have a closed circle or an open circle? Closed circle. Is my arrow going to go to the right or to the left? Left. Okay? It doesn't have to be all pretty and perfect, you know. Okay? P has a minimum of -5. Ooh. P has a minimum of -5. What are we going to use? What symbol? Greater than or equal to -5. So, like I said, I'm going to put 0 here. 1, 2, 3, 4, 5. Here's -5. Am I going to have a closed circle or open circle? Closed. And which way am I going to go? To the right or to the left? Right. To the right. Okay? Ooh, look at this one. X does not equal 0. So does it include 0? No, so I'm going to have an open circle on 0. Can it include everything less than 0? Okay. Can it include everything greater than 0? Oh, look at that, huh? A number X is not equal to 0. So you get it, you got 3 different representations, and you're just writing, and this could be different ways to be said, okay? So as long as you have a way that accurately describes what this means right here, you're good to go, okay? So X is greater than or equal to 1/2 is the easiest one, or X is at least 1/2 would work, wouldn't it? Okay, so now I've got, I don't know, 0, I've got 1. I actually could make this like this. I could make this so this is 1/4, 1/2, 3/4. Here's 1, and here's my 1/2. You can do whatever you want with this number line and create it how you want it to depict it. All right, so am I going to include the 1/2? And I'm going to go which way, right or left? Right. So here, a number X is greater than or equal to 1/2. Okay. Who wants to tell me what this one says? Number 6. So X is greater than or equal to -1. So a number X is greater than or equal to -1. Somebody else, what about number 7? Okay. Let's think of a different way to say that. What could we say here? Is fewer than a number X is fewer than 3, just to mix it up a little bit and we get more familiar with the language that could be used. All right, we got 2 more sets of notes. Actually, we have 3 more, but we'll do very little on the back. Okay. And then I'll look at your homework and see if I can cut it down. You can solve inequalities the same way that you solve equations by using inverse operations. The only difference is that when you are not finding one solution for a variable, you are finding infinitely many solutions. Hence the reason you graph the solution on a number line. 2 less than 3 times a number, x, is less than or equal to negative 14. So we've got that standard less than. Remember what that means? I keep pointing it out. How do I represent 3 times a number? X. 3x. And I have how much less than? 2 less than is less than or equal to. Ooh, better not use that symbol, huh? Less than or equal to negative 14. Are these getting easier? I sure hope so. So let's do something here. I've got to add 2 to both sides. All right, I'm going to put 3x is less than or equal to negative 12. Divide both sides by 3. Am I dividing by a positive number? Okay, and remember it could be dividing or multiplying depending on what is in front of that x, okay? As long as it is positive, you leave the sign the same, okay? So it's x is less than or equal to negative 4. Doesn't matter what the solution is. The solution can be negative. It is what did you divide by. So if I have negative 4 and it has to be less than or equal to, I just come over here and go boop, and I'm done. Now, if I went back and checked, 3 times negative 4 is what? Come on, 3 times negative 4, negative 12. And negative 12 and minus 2 is what? Negative 14. Isn't that equal to negative 14? So, there's your check. Many of you I wrote on your papers from this weekend. Are you doing your checks? Are you doing your checks? I must have said that 20 times. Okay? I'm telling you, it'll save your butt every time. Okay? All right, here we go. I'm going to do this one down here. 3 is greater than or equal to 4d plus 7. Okay? Subtract 7. Now, these get tricky. Okay? Less than or equal to, and I'll show you why. Okay? Now divide by 4. D is less than or equal to negative 1. Now, that is very hard to read for all of you, and it would be very hard for me to read it first. I would rewrite this, make sure, because you keep the sign the same way, D is less than or equal to negative 1, so you know where to put it on the number line. Does that make any sense to you? Because otherwise you're looking at it going, oh, don't know which way to go. Did you need some help? What do you mean change what way? No, it's just easier to graph if I say it that way. Because if I said negative 1 is greater than or equal to D, I'm going to come over here and I'm going to go to negative 1 and I'm going to say, ooh, which way do I go? Does that make any sense? It's more confusing to try and figure out that you need to go up because you need negative 1 to be greater than or equal to negative 1. Okay? Here it's easy. D is less than or equal to. Look at, I went the wrong way. Do you see how you can get turned around very easily? Okay? So it's always easier with inequalities if you're having to put them on a number line to rewrite them because negative 1 is greater than or equal to D. Well, that means D has to really be this way, doesn't it? Because this is where it's greater. D has to be less than or equal to negative 1. Do you see how it's so much easier to see when you rewrite it this way? Okay, that's why. I got one. It's over there. And it has a charger. You can do anything you'd like. Oh, there you go. Entertain them. We won't record you. Hi. He's happy. He got his work done before he even came to class. That's how it's going. Right?
Awesome.
So far, you have not run into any problems with regards to solving inequalities and graphing them. The inverse operation has worked thus far. However, when you divide or multiply by a negative number, it will require a little more work to get the appropriate answer. By a negative, divide or multiply by a negative number. That is your key. Okay? You flip the sign at the end. Okay? And I'll show you what I mean. Negative 2x is greater than 6. Negative 2x is greater than 6. I need to divide by negative 2. So divide this side by negative 2, divide this side by negative 2. As soon as I divide it, I'm flipping my sign. Then I'm going to write my x and negative 3. Did you see what I did? And you should have learned this last year when you did inequalities. Look at you guys, look at me. Like, are you nuts? Okay? Nobody did inequalities?
No. We didn't get this far.
Oh. It's hard? This is hard? Yeah. All you do is if you multiply, all you have to remember is the rule. Multiply or divide by a negative number. When you're doing inequalities, flip the sign. That's all it is. It's not hard. Okay? So, here's my 0, 1, 2, 3, negative 3. I've got an open circle because I don't have an equal sign, and I want my x to be less than negative 3. This is why, and I'll show you. Okay? If I make x negative 2, okay, if we had not flipped the sign, and I put in negative 2 here, negative 2 times negative 2 is greater than 6. What do I get? 4 is greater than 6. Is that a true statement? No. But if I have x is less than negative 3, if I was to put a negative 4 in here instead, negative 2 times negative 4 is less than negative 3. I get what? Oh, 6, I'm sorry. Is less than 6. I get 8. What did I do wrong? Oh, I know what I needed to do. I am so dumb. Oh, okay, well, don't worry about it. Just remember the rule. Flip the sign. Okay? Alright? When you divide or multiply by a negative. Alright, here we go. 2h minus 13 is less than negative 23. Add 13, add 13. 2h is less than negative 10. Am I dividing by a negative? So I'm not going to flip the sign. H is less than negative 5. I'm stressing somebody out. So, say this with me. On inequalities, if you divide or multiply by a negative, flip the sign. That's all there is to it. Special cases. Let's go from the special cases. Chill? Oh, I love algebra. All right, here we go. If I bring this 4x over here, what happens? 0 is less than or equal to negative 7. Is that a true statement? Lord have mercy. Is 0 less than negative 7? What?
Wait, I was saying no at first, but they were like, what are you saying?
Well, what are you going to do when the rest of them jump off the hill and onto go play in the middle of the freeway? You're going to go play in the middle of the freeway? Okay then. Come on, come with us. Okay? I mean, come on. Is 0 less than or equal to negative 7? So it is a false statement. So what do we call that when it's a false statement? No solution, or the empty set. Oh, let's see about over here with inequalities, special cases. 5x plus 7 is greater than 5x minus 8. Bring my 5x over. Uh-oh. 7 is greater than negative 8. Is that true? Okay, hold on.
Well, that's true.
That's true. So now what is it going to be?
Yes, solution.
What solution? What is the solution? It's a test question, people. What's the solution? The set of what? Yes. The solution is the set of all real numbers. I just said yes. What do both the special cases have in common? What happens? What happened to both of them? What do they have in common? Very good. The x terms cancel out. How do you know if the answer is empty set or all real numbers? If the statement is true, then always the set of all real numbers. And it's a fancy R, and I don't know how to do all that curly stuff, okay? If the statement is true, then always it's the set of all real numbers. Okay? If the statement is false, then always and we call that empty set, we call that null, we call that, what else? No solution. All those things can be called. Oh, we're doing pretty good. We are. Your brain's going to pop? Well, then let's do some easy stuff. It says solve and graph the following inequalities on your own number line. Ladies and gentlemen. So, what am I going to have to divide by here? So what am I going to do to the sign before I even do anything else? Flip it and put m is greater than negative 4. Draw a number line. Here's 0. What did I put 40 for? Then I put negative 1, negative 2, negative 3, negative 4. and I'm going to have an open circle, and I need it to be greater than. That wasn't that hard, was it? No, really.
The second one is,
This one? Excuse me. Fractions are your friends. What do you do here?
Put a 1 in the 0.
How do you get rid of that?
I don't get rid of that.
The J, 1 J.
This is the same as 1/6J.
I just said that.
So what are you going to do to get rid of the fraction? Multiply by the
Inverse.
6 over 1.
Oh, was it the wrong?
6 over 1. J, that cancels the 6's out. J is, no, because it's not a negative, is less than 0. Oh my goodness, here's my number line, here's 0. It's less than or equal to, so a close sign, and I'm going to go this way. That's hard. What about number 3? Let's do number 4. What are you going to multiply number 4 by?
Negative 3 over 1.
Negative 3 over 1. Negative 3 over 1. Now, I'm multiplying by a negative number. What do I have to do to the sign? Flip it. Before I do anything else, I'm going to flip it. I'm going to build a habit. Okay? Boom, boom, see? And I've got negative 3 times 6 is negative 18. It's not hard. Okay? Not hard. But look it, you can do this. Here's 0, write down negative 18 over here, and go, oh my goodness, it's going to be down this way. Okay? You don't have to write all the little hashtag things. Just give me the right side of the number line would be nice. Okay? That's all I'm going over today. Okay? We're done.